The other thing is, how are these two going to hook together? Say, I can hook thumbs to thumbs. Yeah. I can hook thumb to forefinger, thumb to middle finger, thumb to ring finger, thumb to pinky finger. So there's all these different combinations.
Let's talk about carbohydrates for a moment. The molecules expected to provide both energy and structural support, and this is where chemistry gets real. This is way beyond a lot of things that I might even be able to comprehend. Sugars like ribose struggle with instability in water, messy mixtures, unhelpful side reactions. I want to step into carbohydrates for a moment and see why even the very first rung on this ladder of the natural origin of life is so hard to climb. So talk about carbohydrates for a moment and explain on a layman's level how we can understand these things and what the issues are if we're trying to answer this question.
Okay. Well, carbohydrates or sugars, the very problem I was just talking about. What happens is carbohydrates will have multiple sites where there's what's called a chiral or stereogenic center. These can all have a handedness, every one of these centers. And so since you have so many of them, you can have 5 centers, or you can have 4 centers, depending on which particular carbohydrate you're talking about. And so you get vast mixtures, because you get on the ones that have 5 centers, you have 2 to the 5th possible isomers, and the ones that have 4, you have 2 to the 4 centers. The ones that have 3, you have 2 to the 3rd possible center. So you might have 8 possible isomers, and these compound the problem because you have so many different possible isomers, meaning that they're similar in structure, but they're not the same, and only one of those is going to work. And if you have mixtures of them, that gums up the work and it doesn't function. The other thing is, how are these two going to hook together? Say, I can hook thumbs to thumbs. Yeah. I can hook thumb to forefinger, thumb to middle finger, thumb to ring finger, thumb to pinky finger. So there's all these different combinations. And then on the next molecule that it hooks to, again, are all these combinations. That compounds the problem of how you hook these things together. Number one, what is the chemistry that you use to hook them together? Nobody knows what the chemistry is on a prebiotic Earth, because this is where I talk about the free energy is positive. They favor not being together. They don't want to be together. So how do you get them to hook together? Well, in nature, you use enzymes. In the lab, we have these clever techniques that we've figured out. But even with our clever techniques, it's very hard to hook the right one to the right. And so what we do is we block all the other sites and we just hook to the ones that we want to. It's a lot of laborious chemistry. Big problem to solve that. And then we can't hook them together. So we can't make these little things without getting vast mixtures, and we can't hook them together without getting vast mixtures. So this is the genesis of the problem with carbohydrates. It is the most difficult class of compounds. This is and if you have, and then plus carbohydrates can have have a hydroxyl group on the end, which is called the anomeric center, can be up or down. If it's in one configuration, people can, for example, eat it, and you're eating some carbohydrate that you can digest, for example, wheat. But if you have the other configuration, then it's a carbohydrate that we can't eat. That's grass, for example. Our bodies cannot digest that. And that's just a little varying of the hydroxyl group going up or down. Depends on whether we can even use it for food, let alone use it for other biological functions. So this is the problem. If we eat it if we eat grass, for example, it goes right through us. It's called fiber. It goes right through us, but our body doesn't get any content to be able to live off of from that. It might be good for our digestive system, but it's not good for much else in giving us energy. So that's the inherent problem with carbohydrates. That's just one of the four classes of compounds that if you don't get it right, it doesn't work. And it's not like you can mess around with this thing. This has to be right.
Yeah.
None of these problems have been solved with carbohydrates.
And again, I love it, Dr. Tour, where you mention the complexity of all of this. And if you get the chirality of something wrong, it doesn't work. If you flip it on its head, it doesn't work. If it doesn't connect up, or if it creates a mixture instead of the exact right thing, it doesn't work. Again, we understand this now within chemistry, but nature doesn't have a mind. Nature can't possibly comprehend all of this and somehow will it into existence.